So in yesterday's lesson, we learnt how to multiply any decimal by 10, 100, and 1000. And today we're going to learn how to multiply by multiples of 10 instead. So instead of 10, we're going to learn how to multiply by 20 and 30, 70, those sort of numbers. And instead of 100, we can multiply by 200 or 500. Instead of 1,000, we can multiply by 9,000. So these are multiples of 10. That first digit changes, but the remaining digits are still zeros. Now, we're just going to do a quick recap on what we did yesterday. So an example of a problem that we did yesterday was something like this. 7.31 times 10. And we know that when we're multiplying by 10, all we're really doing is shifting all of the digits over to the left, okay? So if we imagine that there's a place value chart here, let's pretend that this is our ones, this is our tenths, and then over here, this is our hundredths. We know that if we move a digit to the right one, so if I take this 7 and move it over here, then I'm just multiplying by 10. So if I want to multiply by 10, all I need to do is just move all my digits to the left one. And that's the same thing as multiplying by 10. The number's getting larger by a factor of 10. But it's not really plausible for us to be creating a place value chart every time we need to do a simple multiplication by 10. So instead of moving all the digits, a cheat or a quick way of doing it is just moving the decimal place instead. Okay, so if all the digits are shifting to the left, then that makes it appear as though the decimal point is moving to the right. So we started off with the number 7.31, and we needed to multiply by 10. So what I'm going to do is I'm just going to move this decimal place over one jump to the right. So my new decimal point will be here. My old one disappears. And I can see that I get the same answer by simply moving the decimal point. So I don't have to shift all the digits. It's a little bit difficult to do that using pen and paper. But it's really easy to just move a decimal point because it's just a dot on the page. So we'll try one more example like this. Another example might be something like 62.1 times 100. And the only thing that's really different about this is that we're actually multiplying by 100 instead of by 10. So because we're multiplying by 100, we actually have to take a look at that and say, well, multiplying by 100, that's actually the same thing as multiplying by 10 and then by 10 again. Because 100 is the same as 10 times 10, isn't it? So if I want to multiply something by 100, all I need to do is multiply it by 10 and then by 10 again. So now it's really the same as the previous question, except instead of one jump, we're going to do two jumps. So we've got our number 62.1, and instead of moving just one jump to the right, because I've got two tens here, I need to do another jump to the right again. So my new decimal point goes there. Now I have also got this space here. There's no digit here. So what we do is we just put a 0 there. And our new number, remember this is no longer here. Our new number is 6,210. So 6,210. That is the product of these two numbers here. Okay, now what if we want to multiply it by a multiple of 10 instead? So I might just rub this out. And we'll have a look at a different example now. So let's have a look at something like 3 times 30. Now, I know that times means groups of. So I can actually restate this question as 3 groups of 30, right? And you might be able to work that out right away. 3 groups of 30 is not too difficult to visualize, is it? It's just 30 plus another 30 plus one more 30. That's 3 30s, or 3 groups of 30. And 30 plus 30, that's 60, plus another 30, that's 90. So already I've worked out that 3 times 30 is 90. And that's an easy one because there are only 3 groups of 30. But something like 9 times 30 can be a little bit trickier, as it's more difficult to add up 30 plus 30 plus 30 plus 30 plus 30 plus 30 plus 30 until you have 9 30s, right? That's a bit more of a complicated problem than just 3 30s. So how can we make this problem easier to solve? What can we do? Well, 30 is how many groups of 10? 30 is actually 3 groups of 10, right? So we can actually rewrite this question. We can say that instead of 30 here, we're actually going to say that's 3 lots of 10, 3 groups of 10. And I'm still going to include my 9 times 3 lots of 10. Does this make it easier to solve? Well, it does, right? Because we can easily work out 9 times 3, and then we know how to multiply by 10, right? Whenever you're multiplying by 10, all you need to do is just shift the decimal point. So if I can do 9 times 3 and then multiply by 10, that's a really easy way of working out this question. So what's 9 times 3? 9 times 3 is 27. Then I still need to multiply by 10 as well. And when I multiply by 10, all I need to do is take my number and shift the decimal point. So at the moment it's a whole number, so it's almost like the decimal point is here, and then there's just 0 tenths, 0 hundredths. So I need to shift this over to the right one. So my new decimal point is there, and I've got this space here where there's no digit, so I need to put a 0 in there. Okay, done. So 9 times 30 is 270. All right, let's try another example. Just clear that. Okay, another example is 7 times 600. Now, can I split up this 600 so that I'm only dealing with numbers like 10, 100, and 1000? What can I do to split up 600? 600 is the same as 6 lots of 100, isn't it? So if I change this to 7 times 6 times 100, that makes it easier for me to solve. Because now, as long as I know my times tables, I can do 7 times 6, and then I just have to multiply by 100, which we know all we have to do there is just shift the decimal place twice. Because there's 2 zeros now. 100 is 10 times 10. So we have to do 2 jumps. So 7 times 6 is 42. And I still need to multiply by 100 here. So I need to shift my numbers over, or shift my decimal place to the right. So if I've got the number 42, my decimal point is here. I'm going to shift that 2 jumps to the right. So now my new number is 4,200. So 7 times 600 is 4,200. And we'll do one more example. $12 times 2,000. Okay, can we break up 2,000? 2,000 is the multiple of 10, so let's see if we can make this more simple. Let's rewrite it. 12 times, instead of 2,000, I know that 2,000 is just 2 lots of 1,000. So I can write 2 times 1,000. And now this makes it much easier. 12 times 2 is 24. I still need to multiply by 1,000. And I know that when I'm multiplying by 1,000, because I've got 3 zeros now, 1,000 is the same as 10 times 10 times 10. All I have to do is I have to jump 3 times. So I'll take my number, 24, and I need to move my decimal point 3 jumps to the right. Okay, so my new decimal point will go there, and I need to fill in these zeros as well. So 12 times 2,000 is 24,000.